All right. Good afternoon, everyone. I'm Travis Smith. I work for, sorry, I work for Atlassian. We make a few software products, HipChat, Bitbucket, Confluence, Jira, and I'm an evangelist, and so I pretty much work on developer.atlassian.com, helping people extend our products. But today, I want to talk to you about science. And we're going to start off with an origin story, because I kind of like those, and I think they're fun. So take a look at me. This is me when I'm like 9 years old, setting fire to something with onlookers. And in reality, I feel like that's a pretty good metaphor for what the rest of my life is like. And in case that isn't clear to you, don't allow me to deploy things to production. But I'm doing what people do, trying to explore your world and understand how it works, of course, by fire. Shortly after that, I discovered a talk by Richard Feynman. Like the text of it, I wasn't there at Caltech, I'm not nearly that old. And I read through that, and I was really excited by the possibilities of what his talk was describing about the infinitesimally small things that exist, and what was there, and what the exploration of that world would be like. So this set me on a track where I was sure for the rest of my life that I wanted to be a nanophysicist. I was really excited about that. So I set along that path, and I went to school, and I got an education in, my degree's in computational physics, but I effectively did it. I was doing research like this, where we would run simulations on depositing atoms on substrates and figuring out what happened at different temperatures and different environmental variables. So I actually did that. I even have a fancy diploma that is packed away somewhere, so don't ask to see it. I don't know where it is. But I thought this was really cool, and that's where I ended up, working on these things that were really small. But as it turns out, I didn't really like working in academia. And so during that whole time, writing simulations on actually supercomputers, I developed a lot of computing skills. And so that's where I ended up, actually, was in software, because of these other skills that I developed along the way. And today, I don't really use my science background that much. It's come up a few times, and I've done a few jobs where it's been useful, but it hasn't been that important. But I still really like science and the thought of exploring my world. Now, I have a young son. He's 2, and he likes to explore his world, admittedly a little bit differently than I do at this point. But I think about things on, like, how do I encourage him to explore the world and other things like that? And how can I use software to make that step? And at Atlassian, we have what we call 20% time, or innovation time, and we can work on, whatever projects. So one of the things I've been working on is finding out ways to really encourage this with my son. And so the first thing that is, and you can sort of see, that's a picture of the moon. And my son really likes the moon. Like, he calls it out, he asks where it is. We know it's in the sky, and sometimes it hides and stuff like that. But it's not that easy just to walk outside and see the moon, because the moon has different phases of when it's in, and it's also, I'm probably a strict parent by not allowing my son to stay up really late when he can go out and see it. So this is a picture at like 5 p.m. or something, where it's sunny, but we could lay on the grass and look up at the sun. Though admittedly, it's just a crescent there and not the whole thing. So this comes down to the problem statement. How do I know when the moon is clearly visible in the sky and it's a reasonable time to go out and look at it? And this means a couple of things. How is the moon visible in the sky? Well, it's above the horizon, and the sun's not near the moon, because if the sun and the moon are near each other, you're just going to be blinded by the sun anyways. And then you can also tie in, like, is it clear out? I mean, there's weather information that you can get at. Sometimes it's easy, sometimes it's not. Figuring out where the sun is actually pretty easy. This is a simplified equation for finding the declination of the sun at a given point. You would also need the ascension. Those are the two things used to describe something in the sky. And you can get to this equation with some algebra, and it takes a little bit of work, but luckily Wikipedia does all the algebra for you, so I could just cut and paste the equation and answer that. I could probably get there, but I'm a little rusty on it, so thanks for that, Wikipedia. But it turns out I don't really care to do the math. The math isn't the important part. The answer is. So there's some libraries that handle that for you, or other services out there. But it turns out the moon's a little bit harder because the moon does not have a regular orbit. It has, well, we have things like blue moons when the moon is closest to the Earth or farther away, so there's some permutations around there and whatever else. It's complicated. But to get started down this path, I started we'll just start with a little detour on ChatOps. And I don't know about the rest of you, but I spend my entire day in HipChat, our chat program. My team's totally remote, so it's not even like I can turn around and tap someone on the shoulder to get some information. Everything comes through here. Our builds come through here, our deploys come through here, other warnings, we have other APIs that we've tied up here. So I started by just, all right, well, what's the first thing that you need to get started down here? And that is understanding your latitude and longitude. And actually, it's really easy to write a service to ask Google, given a location, what's geocode that location and give me a latitude and longitude. And to test this stuff out, so I'm not always testing in like a console or something else, it's really easy to wrap it up and actually expose it into HipChat. And then you can have it pop up something else like that. So what I've done so far is just collect all of these things together into minor microservices where you can just start asking questions and tie that all together. Now, I'm not quite here, but the next step is I got a Raspberry Pi 2, a touch screen, a little Wi-Fi adapter, and I want to put a little screen on there that collects all this data together for my son and mount it on the wall somewhere so he can go and point to it and say, hey, the moon's there or not, and we can go look at it. And so that's sort of the culmination of my science project for that, using a collection of services that are really small, using some hardware, and keeping my son interested. I have some other science projects that I've also been working on, but we don't really have time to dig in today. So the takeaways are science is cool, and think of ways that you can explore your world around you. There's a talk that got me to be a physicist. There's plenty of room at the bottom. There's a link to setting up that geolocation thing in HipChat, which is pretty simple. There's a Python library, which is what does the calculations for the moon. PyEFM, I guess, is how you would say it. I'm not really sure. And then check me out on Twitter. And I would enjoy the opportunity to talk with you, any of you, about other science projects some other time if you come and find me. But there's my time. So thank you.